When you carry out a chi-square test using a contingency table, you may be wondering, is it a test for independence or a test of homogeneity? To answer this question, well, look at the full name of the test. The test for independence of two categorical variables in one population. For this test, we have just one population and one sample from this population, and we look at the values of two categorical variables. So we have categorical variable number 1 and its categories or values. Those label the rows of the table. And we have categorical variable number 2 with its categories or values, and those label the columns of the table. So it's one population and two categorical variables. The other test is the test of homogeneity of two or more populations with respect to one categorical variable. Thus, there is only one variable and there are several populations, two or more populations. And accordingly, there are several samples, one from each population. So the sample data are distributed in the columns, and then categories of that one and only categorical variable label the rows of the table. In this test, we try to determine whether the distribution of this variable is the same in those several populations. Let's look at the hypotheses in these two tests. In the test for independence, the null hypothesis reads, the two variables are independent in the source population, and the alternative, the two variables are not independent in the same population. In the test of homogeneity, the null hypothesis reads the populations are homogeneous with respect to the variable. That means that the distribution of this variable is the same in all populations. Now, the alternative hypothesis is that the populations are not homogeneous with respect to the variable, meaning that the distributions are different in these populations.